Hello, this is the fourth video about matrices, matrix multiplication. In the last video, we learned basic matrix multiplication and division. Now let's get started to our new topic. There are three main rules of matrix multiplication. The first one is while you are multiplying two matrices, they don't have to be the same size. The second one is the inner dimensions of the sizes must agree, and the third one is the size of the resulting matrix is the outer dimensions of the originals. Let's suppose that you have matrix X, which is 4 by 3, and you have a matrix Y, which is 3 by 5. As you can see, they are not in the same size, but if we want to multiply matrix X times matrix Y, we have a 4 by 3 and 3 by 5. Let's look at the second rule. It says the inner dimensions of the sizes must agree. As you can see, let me write for a second. Their inner dimensions are both 3. Here we are able to multiply them. And the third rule explains that the size of the resulting matrix is the outer dimensions of the originals. Here original matrices are 4 by 3 and 3 by 4. In this case, our matrix is going to be F4 by 5. Even we had two matrices at the same size, 2 by 2, this doesn't mean that Z times T and T times Z is equal. This is very different than any other multiplication. Order is important thing in this multiplication, so it doesn't matter which way you multiplied them. As an example, we are going to multiply the two matrices, X and Y. Let me write them for you. X is 4 by 3 and Y is 3 by 5. Here, as you can see, the inner dimensions of the 3 and they agree. And the resulting matrix is 4 by 5. In this case, the multiplication of two matrices is quite different than the regular multiplication. Let's start by making a space for our final matrix. Every element of this matrix is calculated equally. To calculate the first part, which is xy of 1, 1, we have to calculate the first row of X and the first column of Y. Let's write those here. The first row of X is 3, 11, 9, and the first column of Y equals 3, 6, 5. For xy of 1, 1, we calculated by 3 times 3 plus 11 times 6 plus 9 times 5, which is 120. So this is how we calculate these matrices. For multiplication of xy to have one number in this first element, we want the complete row of x and the complete column of y. Calculating it, we have to multiply the first element of the first row of x and the first element of the first row in y, which is 9, and add to it the second element, x, and the second element in y, which is 66, and add it to the third element in x and y, which is 45, to get 120. For the next part, xy of row 1, column 2, we want to get row 1 of x and column y, since this is in row 1, column 2, xy. Row 1 is still 3, 11, 9, and column 2 is 17, 5, 16. To multiply these together for xy 1, 2, it's 3 times 17 plus 11 times 5 plus 9 times 16, which is 250. You have to do that for every single element in xy. Let's say you had an even larger matrix. You're multiplying a 9 by 4 with 4 by 11. Your resulting matrix would end up being 9 by 11. that will be extremely hard to calculate by hand. These two matrices, 4 by 3 and 3 by 5, in a normal multiplication, you would be able to switch multiplication around and multiply it in the other direction. But in this case, if you switch the places of matrices, inner dimensions wouldn't agree. But if you had two square matrices like 2 by 2, you would be able to change the places of the two matrices in both cases. Your resulting matrix would be 2 by 2, but Z and T are different matrices. If you were to reverse the multiplication, you would most likely to end up with a different matrix. There are two special types of multiplication. The first type is when you multiply a square matrix, which is its identity. If you have a square matrix such as 3 by 3 and you multiply it by the identity, you would get back the same 3 by 3 matrix. If you had the square matrix K, which is still 3 by 3, and you multiplied it by its own inverse, but you would get back instead its identity matrix. This was the fourth video of matrices, and our topic was matrix multiplication. I hope you liked the video. Thanks for watching.